So in the last class, we have looked up on linear filtering of long data sequences, and we were looking at a specific method called as overlap save method. So അതിന് ഒരു example ആണ് നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സിൽ പറഞ്ഞത്. So let us just briefly look at in theory how this is working, how the linear filtering using overlap save method is working. Okay, so basically what our aim is to filter or do a linear filtering of long data sequences. Okay, so basically you have an input signal. Let's say it's a very lengthy input signal, which I represent it as something like this. It's a very big block. Okay, and then we need to do, or we need to pass this huge input signal, which consists of long data sequences, into a filter whose impulse response is h of n, and we need to get an output for that. Okay, so what we did in overlap save method is as follows. First, initially you have appended m-1 zeros to the data block. Okay, so remember, the length of h of n is equal to m. M is the length of the filter or the system that you are going to use to pass this input data. Okay, so in that system, you first append x of n with m-1 zeros. Okay, so here you are appending m-1 zeros. Okay. So x of n is this huge, very lengthy data block. Okay. Next, what you do is you are going to divide this individual or the complete data block into small segments or small blocks, each of length n, out of which L length is from x1 of it, or from each block. That is, so you have something like this. Okay, so this is the first m-1, which are all zeros. Okay, and this is your length L. So you see, you take first, so let me put x of n here. You take first a length L of your complete data block, input signal. Input signal in L length എടുക്കുന്നു. അതിനോട് കൂടി m-1 zeros already append ചെയ്തു. So this is your x1 of n. Okay, അതിന്റെ x1 of n ന്റെ കൂടെ m-1 zeros append ചെയ്തു. Then again you will take another data block of length L. Similarly, you take another data block of length L, and till it reaches the end of the complete input block. അങ്ങനെ നിങ്ങൾ ആ complete data you have segmented each of length L. So let me just mark this with red. Okay, and each time when you take that data block, you have another x2 of n. Okay, so the first one is x1 of n, the second one is x2 of n, which is of length L. Okay, this is second block. This is third block. And finally, you have the last block. Whatever length are different, but actually all the lengths are same. Okay. Let me just so these are the different blocks. ഇന്നലെ കഴിഞ്ഞ ക്ലാസ്സിൽ കണ്ട പോലെ we have divided it into multiple blocks. In ഓരോ ബ്ലോക്കിന്റെയും when you take the first m-1 part, it is basically from the previous block. Okay, so you can say the first m-1 part, which is this, it is from the previous block. Previous ബ്ലോക്കിലുള്ള ഫസ്റ്റ് m-1 പാർട്ട് എന്താണോ അതായിരിക്കും കറണ്ട് ബ്ലോക്കിലെ പ്രീവിയസ് ബ്ലോക്കിലെ ലാസ്റ്റ് m-1 പാർട്ട് എന്താണോ അതായിരിക്കും കറണ്ട് ബ്ലോക്കിലെ ഫസ്റ്റ് m-1 പാർട്ട്. m-1 from x1 of it. Similarly, you take here your m-1 part, it will come as the first m-1 of the current block. This is m-1 from x2 of. Similarly, the last part you have m-1 from x3 of. Okay, so now you can see that you have created those block structures. Each block is have L points of the input signal. It is appended with m-1 points of the previous signal to its initial position, and you create each and every block. Okay. Now, once you do this, then you use h of n to compute the y of n. Okay. So to create y of n, so your y of n length is same as that of the length of n. N is equal to L plus m-1. So this is your first y1 of n. Okay. Similarly, this is your second, which is y2 of n. And this is your third, y3 of n. And finally, this is your fourth, y4 of n. Where y1 of n is x1 of n convolution h of n is y1 of n, x2 of n convolution h of n is or x1 dash, which is the complete block, is y2 of n, x3 dash of n convolution h of n is y3 of n, and x4 dash of n convolution h of n is y4 of n. Okay, so this complete block is called as x1 dash of n. Similarly, this complete block is called as x2 dash of n. This complete block is called as x3 dash of n. And this complete block is called as x4 dash of n. x1 dash of n, when you convolve with h of n, you will get y1 of n. x2 dash of n, when you convolve with h of n, you will get y2 of n, and similarly others. ഈ ഓരോ ബ്ലോക്കിലെയും you will disregard or you will just neglect the first m-1 points. ഓരോ ബ്ലോക്കിലുള്ള first m-1 points you will just neglect. Okay, so this m-1 points is neglected. Similarly, this m-1 points are neglected, and here also m-1 points, here also m-1. Then you combine together y1 of n, y2 of n, y3 of n, y4 of n till the end of the outputs. You append them together in order to create your final y of n. Okay, so this is your block diagram for overlap save method. Overlap save method question vannu kayinjal, make sure you draw this block diagram. If it is a theory question, make sure you draw it properly. If somebody sees the block diagram, immediately they will give you the mark. Okay, നിങ്ങൾ ആദ്യം എക്സ്പ്ലനേഷൻ എഴുതിയില്ലെങ്കിലും make sure you draw this block diagram. It's very simple block diagram. ഇൻപുട്ട് സിഗ്നൽ എടുക്കുന്നു, അതിനെ നിങ്ങൾ മൾട്ടിപ്പിൾ സ്മോൾ എൽ ലെങ്ത് ഉള്ള സെക്ഷൻസ് ആയിട്ട് അല്ലെ എൽ ലെങ്ത് ഉള്ള ബ്ലോക്സ് ആയിട്ട് ഡിവൈഡ് ചെയ്യുന്നു. ഓരോ ബ്ലോക്കിലും നിങ്ങളുടെ പ്രീവിയസ് ബ്ലോക്കിന്റെ m-1 പോയിന്റ്സ് അപ്പൻഡ് ചെയ്യുന്നു. എന്നിട്ട് ഓരോ ബ്ലോക്കിനെയും നിങ്ങൾ h of n ആയിട്ട് ലീനിയർ കൺവല്യൂഷൻ ചെയ്യുന്നു. യു വിൽ ഗെറ്റ് ദ ഔട്ട്പുട്ട് y of n. ആ ഓരോ ഔട്ട്പുട്ടിന്റെയും ഫസ്റ്റ് m-1 പോയിന്റ്സ് നെഗ്ലക്ട് ചെയ്യുന്നു. എന്നിട്ട് എല്ലാ ഔട്ട്പുട്ടും കൂടെ ഒരുമിച്ച് ചേർത്ത് ഓർഡറിൽ ഒരുമിച്ച് ചേർക്കുന്നു. യു വിൽ ഗെറ്റ് ദ ഫൈനൽ ഔട്ട്പുട്ട്. ദിസ് ഈസ് കോൾഡ് ആസ് ഓവർലാപ്പ് സേവ് മെത്തേഡ്. ഓക്കെ, ഇനി ഇതേപോലെ തന്നെ there is another method which is called as overlap add method. Just like we did linear filtering of a long data sequence using overlap save method, you can also do linear filtering of long data sequences using overlap add method. The procedure is exactly same, steps are almost similar, but there are small differences. Instead of neglecting many things, we are going to add many things. Okay, so if you understood overlap save method, then overlap add method is just a piece of cake. But anyway, we'll try to do this using a simple problem. Okay, so the question is like this: for h of n is equal to 3, 2, 1 and x of n is equal to 1, 2, 3, 3, 2, 1, minus 1, minus 2, minus 3, 5, 6, minus 1, 2, 0, 2, 1. Find the output using overlap add method. Assume block length as 7. Without a question. Well, in this question, we want to find the output or the output of a linear convolution of this x of n, which is a very lengthy sequence, convolved with h of n, which is 3, 2, 1, 1. I think there is one missing. 3, 2, 1, 1. We get the output using overlap add method. and they have given the block's length also as 7. Okay, so let's first list all the things that is being given. So you can see that you have already given h of n, which is 3, 2, 1, 1, which means the value of m, which is the length of h of n, is equal to 4. So put it in box. Okay. Now, if you look at x of n, it's a very lengthy sequence, but we need to have a block length of only 7. So, if you remember previously, the first step, which is also the step here, is to fix block length n. So, in our case, n is already given, so n is equal to 7. So, we don't want to fix it by ourselves, it is given in the question. Next is you need to fix L. L is how many points of x of n are you taking into the block at a time. And you know that n is equal to L plus m minus 1. This is always true, whether we are using overlap add or overlap save method. So you know the value of n, which is equal to 7. You know the value of m, which is equal to 4. So implies the value of L is equal to 7 minus 4 plus 1. That is equal to 4. So you have fixed the value of L is equal to 4. So you have fixed all the lengths that is needed to create each and every block. Fine. Next, make the length of h of n same as that of capital N. That is, in step 2, make the length of h of n is equal to n. So in our case, n is equal to 7. H of n is equal to set 3, 2, 1, 1. So that is 3, 2, 1, 1. So if you want to make it of length 7, you need to add 3 more zeros. So make the length of h of n equal to n by adding L minus 1 zeros. So you see we have padded L minus 1, that is equal to 4 minus 1, 3 zeros to h of n, which will make h of n same length as of the block, which is capital N, that is equal to 7. Okay. Now, step 3. Divide x of n into sub-blocks or subsequence each of length L. So you see x of n is a very lengthy sequence here. Okay. And we need to divide this into subsequences. ഓരോ സീക്വൻസ് അല്ലെങ്കിൽ ഓരോ ബ്ലോക്ക് സബ് ബ്ലോക്സ് ആയി ഡിവൈഡ് ചെയ്യണം ഈ കംപ്ലീറ്റ് എക്സ് ഓഫ് എന്നെ. ഓരോ ബ്ലോക്കിന്റെയും അല്ലെങ്കിൽ ഓരോ സീക്വൻസിന്റെയും ലെങ്ത് എന്ന് പറയുന്നത് ഇറ്റ് ഷുഡ് ബി ഈക്വൽ ടു ക്യാപിറ്റൽ എൽ, വിച്ച് ഈസ് 4. Okay. So let's divide that. Okay, so let me write x of n once again. Okay, so your value of L is equal to 4. So you need to divide x of n into multiple blocks. Each block should have only 4 elements. So the first block will be this, second block will be this, third block will be this, and finally the last block is this. Okay. Luckily, we don't want to pad zeros in any of the blocks. കാരണം L equal to 4 ആണ്. നമുക്ക് x of n 16 elements ആണുള്ളത്. Okay, so we don't want to add any zeros, or just like we have did in the previous question, we don't want to add or pad any zeros. We can exactly divide x of n. Okay, so let's divide x of n. So x1 of n is set 1, 2, 3, 3. x2 of n is equal to set 2, 1, minus 1, minus 2. x3 of n is equal to minus 3, 5, 6, minus 1. And x4 of n is equal to minus, sorry, 2, 0, 2, 1. So we have divided into 4 different blocks, each of length L equal to 4. Next, step 4, make each subsequence of length L to length capital L. That is, if you see each of his x1, x2, x3, x4 has a length is equal to 4, we need to make each of this of length n, which is equal to 7, by padding m minus 1 zeros. That is, you need to pad 4 minus 1, that is 3 zeros in each subsequence. So your new x1 dash zeros at the end. That is really important. At the end of each subsequence. So not difference here. Overlap save മെത്തേഡിൽ നമ്മൾ സീറോസ് പാഡ് ചെയ്തുകൊണ്ടിരുന്നത് n ലെങ്ത് ആക്കാൻ വേണ്ടിയിട്ട് we had put previous ബ്ലോക്കിന്റെ m-1 പോയിന്റ്സ് കറണ്ട് ബ്ലോക്കിന്റെ ആദ്യത്തെ m-1 പോയിന്റ്സിലേക്കാണ് ഇട്ടുകൊണ്ടിരുന്നത്. പക്ഷെ ഓവർലാപ്പ് ആഡ് മെത്തേഡിൽ you don't need to put anything from the previous block. കറണ്ട് ബ്ലോക്കിലെ അവസാനം സീറോസ് പാഡ് ചെയ്താൽ മതി. You don't want to add or you don't want to put anything from the previous block. Okay, so your x1 dash of n will now become 1, 2, 3, 3. So you want to pad m minus 1 zeros. M minus 1 is 4 minus 1, that is equal to 3. So 0, 0, 0. Now you see that the length of x1 dash of n is 7. Okay, so you have padded m minus 1 zeros. Okay, so similarly, you can do x2 dash of n, that is equal to 2, 1, minus 1, minus 2, and you pad m minus 1 number of zeros. x3 dash of n, which is equal to minus 3, 5, 6, minus 1, and you pad m minus 1 number of zeros. And finally, x4 dash of n is equal to 2, 0, 2, 1, and you pad m minus 1 number of zeros. So now each of the block has a length of 7, which is equal to n. Your h of n, already we have made its length equal to n, which is equal to 7. Okay. Now, in the next step, you do the convolution of each block separately with h of n. That is, in step 5, circular convolution of each block with h of n. Okay, so what you do is you will get y1 of n is equal to x1 dash of n circular convolution h of n. So if you do the circular convolution, you will see that you will get the result as 3, 8, 14, 18, 11, 6, and 3. Okay. Similarly, y2 of n is equal to x2 dash of n circular convolution h of n. That is equal to 2 minus 1, sorry, 2 plus 1 minus 1. So that is, let me just rewrite it. I don't want to write the complete thing. So you will get the answer as 6, 7, 1, minus 5, minus 4, minus 3, and minus 2. Similarly, y3 of n is equal to x3 dash of n circular convolution h of n, that is equal to minus 9, 9, 25, 11, 9, 5, minus 1. And finally, the last block, when you do the circular convolution, this is equal to x4 dash of n circular convolution of h of n. This is equal to 6, 4, 8, 9, 4, 3, 1. Okay, so you have got the output of individual block. In the last step, there is a difference with the our overlap save method. So in step 6, what you do is you add the first m minus 1 points of the current block with the last m minus 1 points of the previous block. So you see you have like 4 different outputs. 4 ബ്ലോക്കിന് 4 ഔട്ട്പുട്ട് കിട്ടിയിട്ടുണ്ട്. ഇനി ചെയ്യേണ്ടത് കറണ്ട് ബ്ലോക്കിലെ ആദ്യത്തെ m-1 പോയിന്റ്സും പ്രീവിയസ് ബ്ലോക്കിലെ അവസാനത്തെ m-1 പോയിന്റ്സും തമ്മിൽ ആഡ് ചെയ്ത് പോവാം. ദാറ്റ് മീൻസ് യു ഗെറ്റ് സംതിങ് ലൈക്ക് ദിസ്. So y1 of n was 3, 8, 14, 18, 11, 6, 3. So you look at the, so in y1 of n is the first block, so you don't want to add with the previous block only. So but you see this is the last m-1 points. Okay, so when you do the addition with the next block, what you do is you need to add this with the first m-1 points of the current block, which is 6, 7, 1, minus 5, minus 4, minus 3, minus 2. അതേപോലെ തന്നെ when you consider y3 of n, you should consider the first m-1 points, that is minus 9, 9, 25, 11, 9, 5, minus 1. Okay, and when you consider y4 of n, this is equal to again 6, 4, 8, 9, 4. I'm just writing it below, that's all. Okay, so you see here you need to add the m-1 points of the first 3 m-1 points of the current block and the previous m-1 points of the previous block and the last m-1 points of the previous block. Similarly, you need to add these points and you need to add these points. അതായത് ഇപ്പം ഏത് ബ്ലോക്കാണോ കൺസിഡർ ചെയ്യുന്നത് ആ ബ്ലോക്കിന്റെ ആദ്യത്തെ m-1 പോയിന്റ്സ്, ഇതിൽ m എന്ന് പറയുന്നത് 4 ആണ്. സോ ആദ്യത്തെ 3 പോയിന്റും കഴിഞ്ഞ ബ്ലോക്കിലെ അവസാനത്തെ 3 പോയിന്റും തമ്മിൽ ആഡ് ചെയ്യണം. ബാക്കിയുള്ളതൊക്കെ അതേപടി തന്നെ ആയിരിക്കും. പക്ഷെ ഈ ഫസ്റ്റ് m-1 പോയിന്റ്സും കഴിഞ്ഞ ബ്ലോക്കിന്റെ ലാസ്റ്റ് m-1 പോയിന്റ്സും തമ്മിൽ യു നീഡ് ടു ആഡ്. സോ യുവർ ഫൈനൽ ഔട്ട്പുട്ട് y of n is equal to 3, 8, 14, 18. So when you do 11 plus 6, it is 17. 6 plus 7 is 13. 3 plus 1 is 4. Then you do the normal one, minus 5. It is not getting added with anything. Then you have minus 9 plus minus 4, that is minus 13. Minus 3 plus 9, that is 6. Minus 2 plus 25, that is 23. Then you don't have anything to add with 11, so it is 11 will be as it is. And then you have 9 plus 6, which is 15. 5 plus 4 is 9. Minus 1 plus 8 is 7. Then the last points are not getting added with anything, so it will be 9. So it will be 9, 4, 3, 1. So this is your final y of n. Okay, so overlap save method, if you look at overlap add method, in overlap save method we are neglecting the first m-1 points of each block or each output block. Overlap add method നമ്മൾ ആദ്യത്തെ m-1 പോയിന്റ്സും പ്രീവിയസ് ബ്ലോക്കിന്റെ അവസാനത്തെ m-1 പോയിന്റ്സും തമ്മിൽ ആഡ് ചെയ്യുന്നു. അത് അതേപടി ആഡ് ചെയ്ത് എഴുതുന്നു. ബാക്കിയുള്ളത് അതേപടി എഴുതുന്നു. Okay, so you are just adding all these points here, in this case here plus that's the difference, and you get whatever you get after adding and writing the others as it is. That is your final output. Okay, so if you just recap, so this is what you want to find the linear convolution of x of n and h of n, where x of n is a very lengthy sequence, which is block length of, let's say, 7. Very lengthy sequence, which is of length 16. But we need to have an individual block length of only 7, that means capital N equal to 7. H of n, the 4 elements ഉള്ളൂ, so capital N is equal to 4. Okay. So first step, you fix n. n value നമുക്ക് already തന്നിട്ടുണ്ട് 7 ആണെന്നുള്ളത്. So you say n equal to 7. Now we know m, and you know the formula n equal to L plus m minus 1. Linear convolution output എത്ര number of points ഉണ്ടാവും എന്നുള്ള ഔട്ട്പുട്ടിന്റെ ഫോർമുലയാണത്. So you know n, you can find L. So L is equal to 4. Next is you take h of n and you make h of n length equal to capital N, which is equal to 7. Okay. H of n length verum 4 ആണ്. So you add 3 more zeros, which means you add L minus 1 number of zeros. You make h of n also length equal to 7. Next, you divide x of n into multiple subsequences or blocks, each of length L equal to 4. Okay, so you take x of n, you divide this into 4 different blocks. Each has a length L equal to 4. Next, you make each of this x1 of n of length equal to capital N by padding enough number of zeros, or you pad m minus 1 number of zeros. So you take x1 of n, this is this, then you pad m minus 1 number of zeros to make this length equal to capital N. Our same procedure, you repeat it for all the blocks. Okay, and then you do circular convolution of each of this block with h of n, and you will get an output of length equal to 7, which is equal to n. അങ്ങനെ നമുക്ക് y1 of n കിട്ടും, y2 of n കിട്ടും, y3 കിട്ടും, y4 കിട്ടും. Where you are convolving h of n with blocks. നമ്മൾ ഡിവൈഡ് ചെയ്ത ബ്ലോക്സുമായിട്ട് കൺവോൾവ് ചെയ്യും. ലാസ്റ്റ് സ്റ്റെപ്പിൽ you need to add, you write y of n in that order. You add the first m minus 1 elements of the current block with the last m minus 1 elements of the previous block, and you write the rest as it is. Okay, so here you see y1 of n, y2 of n ile y2 of n ന്റെ ആദ്യത്തെ 3 എലിമെന്റ്സും y1 of n ile അവസാനത്തെ 3 എലിമെന്റ്സ് നമ്മൾ ആഡ് ചെയ്യുന്നു. അതുപോലെ y3 of n എടുക്കുമ്പോൾ you see y2 of n ന്റെ ലാസ്റ്റ് 3 എലിമെന്റ്സും y3 of n ന്റെ ആദ്യത്തെ 3 എലിമെന്റ്സും ആഡ് ചെയ്യുന്നു. y4 of n എടുക്കുമ്പോൾ y4 of n ന്റെ ആദ്യത്തെ 3 എലിമെന്റ്സും y3 of n ന്റെ ലാസ്റ്റ് 3 എലിമെന്റ്സും ആഡ് ചെയ്യും. Okay, so you get the output by writing all those elements which are not getting added as it is, and the rest elements by adding. ബാക്കിയുള്ള എലിമെന്റ്സ് എല്ലാം ആഡ് ചെയ്തിട്ടാണ് എഴുതിയിരിക്കുന്നത്. ഈ പച്ചയിൽ എഴുതിയിരിക്കുന്ന എലിമെന്റ്സ് എല്ലാം ആഡ് ചെയ്തിട്ടുള്ളതാണ്. റെഡിനകത്ത് എഴുതിയിരിക്കുന്ന എലിമെന്റ്സ് എല്ലാം it is written as it is, because it is not getting added with anything else. So you see y1 of n is this. Now if you do an actual linear convolution of x of n and h of n without dividing into blocks as we did like this, then you can see that x of n convolution h of n will give the result as y of n, which is this. This is called as overlap add method for linear filter. Okay, so this method is called as overlap add method. നമ്മൾ ഓവർലാപ്പ് ചെയ്തിട്ട് രണ്ട് ബ്ലോക്കിന്റെ എലിമെന്റ്സ് തമ്മിൽ ആഡ് ചെയ്യും. അതും എല്ലാ എലിമെന്റ്സും ഇല്ല, ഒരു ബ്ലോക്കിന്റെ ഫസ്റ്റ് 3 പ്രീവിയസ് ബ്ലോക്കിന്റെ ലാസ്റ്റ് 3 തമ്മിലാണ് ആഡ് ചെയ്യുന്നത്. And then you get the complete linear filtered output. So if you draw the diagram of overlap add method just like we have drawn for overlap save method, it will be something like this. So you have a long data sequence. like this. We're going to divide this long data sequence into multiple small sequences, each of length L. Okay. And then when you make the small sequences, let's say this is x1 of n, you add m minus 1 number of zeros to that sequence or to that block. Okay. So you have in each division, this is x2 of n, you add m minus 1 number of zeros, and again in the last division, this is x3 of n, and you add m minus 1 number of zeros. So it is divided equally, but you are adding m minus 1 number of zeros in each of the division. Okay. Then you do circular convolution with h of n. Okay. And you'll get y of n. Okay. E y of n, you take the last m minus 1 zeros. This is y1 of n. So this is y2 of n. This is y3 of n. ഈ ഓരോന്നിലെ you take the first m minus 1 points of the current block and you add with the last m minus 1 points of the previous block. Similarly, in each and every block, you take the first m minus 1 points of the current block, you add it with the last m minus 1 points of the previous block. The final output that you get here after adding is actually your final output y of n. Okay, so in this one, we'll have an added value here, an added value here. So this is here, this will be the complete y of n, and this portion is the added value. The rest has been written as it is. So here we are, this is m minus 1 points. Here also m minus 1 points. Okay, I hope you have understood this in this diagram. So you have a large data block which is x of n, which has a very large data length. You divide that into multiple small subsequences or subblocks, and then each of the subblock you pad with m minus 1 number of zeros, where m is the length of h of n. So each subblock will be padded with a small m minus 1 number of zeros. And then you do a circular convolution of each of the subblock with h of n. Okay, so this will be your new x1 dash of n. So this is your x2 dash of n, and this is your x3 dash of n, the complete block, including the zeros. So y1 of n is actually x1 dash of n convolution h of n. Y2 of n is x2 dash of n convolution h of n. Y3 of n is x3 dash of n convolution. Okay, and then when you get y1 of n, y2 of n, y3 of n, you add the first m minus 1 points of the current block with the last m minus 1 points of the previous block. Similarly, you add the first m minus 1 points of the current block with the last m minus 1 points of the previous block. And then you put everything in that order. So you write as it is the ones which have not been added. Then you write the ones which have been added. This is the portion which has not been added as it is. This has been the portion which has been added and the portion which has not been added. So that is your complete way of it. Okay. This is called as overlap add method. So these are the two methods which are used to do linear filtering of long data sequences. Long data means you have like millions of points, but you want to do some kind of a circular convolution or linear filtering, or you want to pass this data to some kind of a system, but you can't do the processing of the full data at a stretch. So you divide that into multiple blocks. You do circular convolution with the filtered impulse response, and you get the output. And then you join back together in different way for overlap add and overlap save method to get the output. Okay, any doubts on this? Okay, fine. So I will post the recorded video in the Google Classroom. So make sure you look into this videos, and I will also try to post this notes also in the classroom. This whatever I have written. But please make sure you go and read the textbook, because there are some more representations that is given in the textbook. For example, when you explain overlap add method, after you write this or draw this figure, you need to write that x1 of n is equal to x1 dash of n is equal to x1 of n comma m minus 1 number of zeros. You write that in bracket and all. So please make sure you go back and read the textbook. Okay, then only it will be complete. Right? Okay. So if you don't have any more questions, or if you have understood this, I think we'll stop it here today. Okay, so just give me a second. I need to take attendance. Okay, Abhishek B, you know. Abhishek K, Akhil Darshan, Anbin George, Basil Case, Dhyanjan, Jizin K, Naveen PT, Nawaf Muhammad, Needu Martin, Roshit Ramesh, Safna, Sahir, Siddharth PP, Srishma, Ardra, Abida, CT, Reina Francis. Okay. Okay. Absentees roll numbers 1, 2, 5, 9, 18, 20, 25, 30, 31, 32, 36, 37, 42, 43, 48, 49, 61. ഈ വിളിച്ച റോൾ നമ്പേഴ്സ് ആരെങ്കിലും ഉണ്ടോ ഇതിനകത്ത്? ഇല്ലല്ലോ. Okay. So thank you. Thank you for listening. We'll meet next day.